In 1700, something happened off the Pacific Northwest that sounds almost impossible. A magnitude 9 earthquake struck beneath the ocean. There was no seismograph to record it, no satellite, no warning system, and yet, more than 3 centuries later, scientists know the exact date it happened. They found the first clue in the remains of a drowned forest. The second was buried beneath the coast. The final clue was thousands of miles away in Japan. And together, they revealed a terrifying possibility. The fault that produced that earthquake is still there. So how do you predict an earthquake powerful enough to reshape an entire region when you don't even know when it will strike? Beneath Washington, Oregon, and Northern California lies the Cascadia Subduction Zone, an enormous fault where the Juan de Fuca plate is being pushed beneath the North American plate. The movement is slow, only a few centimeters each year, but parts of the boundary can lock in place while the plates continue pushing. Stress builds silently. And when enough of that locked fault finally ruptures, the result can be a megathrust earthquake approaching magnitude 9. The last time Cascadia did this, the coastline changed in minutes. But scientists did not learn that from an earthquake instrument. They learned it from trees. Along the Pacific Northwest coast, researchers found forests that had suddenly been drowned by seawater. The trees were still standing, but the land beneath them had dropped. Then they examined the tree rings. The final ring showed that those trees died during the winter of 1699 to 1700. That gave scientists a year, but they still did not have the exact date. Then came the strangest clue of all. Thousands of miles away in Japan, historical records described an unusual tsunami arriving in January 1700. The villages reported flooding and damage, but there was a problem. Nobody had felt a local earthquake powerful enough to create it. It was an orphan tsunami, a tsunami with no obvious earthquake. Scientists eventually connected the Japanese records with the drowned forests, tsunami deposits, and other geological evidence along the Pacific Northwest. The answer was extraordinary. On January 26, 1700, Cascadia had produced a great earthquake estimated at roughly magnitude 9. The earthquake was never directly recorded, but its fingerprints were everywhere. And that changed the question. Scientists no longer had to ask whether Cascadia could produce a megaquake. They knew it could. Now they had to ask, when will it happen again? This is where the story becomes much more complicated. Earthquakes do not follow a perfect schedule. Cascadia has produced many great earthquakes over the last 10,000 years, but the gaps between them vary. So, the fact that more than 300 years have passed since 1700 does not mean the next earthquake is guaranteed to be overdue. What scientists can do is estimate probability. The latest U.S. Geological Survey assessment puts the chance of an approximately magnitude 9 Cascadia earthquake at about 10 to 15% within the next 50 years. That is not a prediction. It is a warning about risk. And if a major rupture does happen, the earthquake itself may be only the first stage. The ground could shake violently for several minutes across parts of the Pacific Northwest. Roads and bridges could be damaged. Landslides could cut off communities. In water-saturated ground, liquefaction could cause soil to temporarily lose much of its strength. And along the coast, the most dangerous development may arrive from the ocean, because when an offshore megathrust earthquake suddenly moves the sea floor, it can displace a huge volume of water and generate a tsunami. For coastal communities, the earthquake itself may be the warning. Strong, prolonged shaking means there may be very little time to wait for anything else. Move to higher ground. That is why Cascadia is not simply a story about one earthquake. It is a story about everything that happens after the rupture. But there is one final problem. Scientists can reconstruct the last Cascadia megaquake. They can analyze thousands of years of evidence. They can model different rupture scenarios. They can estimate the probability. What they still cannot do is point to a date on a calendar. There is no countdown beneath the Pacific Northwest. No instrument can currently tell America that the rupture will begin tomorrow, next year, or even within a specific decade. And that may be the most unsettling part. Because the last great Cascadia earthquake is no longer a mystery. We know when it happened. We know the tsunami it created. We know the fault is capable of doing it again. More than 300 years later, the plates beneath the Pacific Northwest are still moving. The next megaquake is not a question of whether Cascadia can produce one. It is a question of when the fault finally lets go, and how ready America will be when it does.